Let's look at the electron configuration of atoms according to the Bohr model, which states that electrons exist in energy levels much like a set of steps. So these energy levels are often referred to as orbitals because that's what the electrons are doing around the nucleus. They're orbiting. First energy level, which is like the first step, can have 2 electrons, and you can see that in this table here. The second energy level can have 8, third 8, fourth 18, etc. Now note, when you get into more advanced levels of chemistry, you'll discover that the third energy level can have up to 18 electrons, which happens to do with the subshells and the different levels of energy. We're not going to get into that at this point in time, but just so you're aware of that so you don't get confused. Now if you look at the diagram down here, you can see how that's kind of pictorially represented. So in the middle here we have the nucleus, and the nucleus holds the protons and the neutrons. So around the nucleus is where we have the electrons orbiting. So this is energy level 1, and then we have energy level 2, and energy level 3. There are, of course, more than 3 energy levels, but that's what's shown in that diagram. So let's look at the energy level of some elements. First one's nitrogen. So if we look at the periodic table that I've provided here, just an excerpt of it, nitrogen is here. Okay, so the atomic number of nitrogen is 7. So we have 7 protons, and because the number of protons equals the number of electrons, we have 7 electrons to place. So looking at the table up the top, we can have 2 in the first energy level, and that leaves 5 left, and because the second one holds up to 8, we can have 5 in the second energy level. So pictorially, we have 2 in the first energy level, that means it's full, and then we have 5 in the second. So 1, 2, 3, 4, 5. Okay, now let's look at silicon. Silicon is over here. So the atomic number of silicon equals 14. So we have 14 protons and 14 electrons to place. So we can have 2 in the first energy level. Second one can have 8. So that's 10. So we've got 4 left to place. Third one can hold up to 8. So we can have 4 in the next energy level. So pictorially, our first energy level is full with 2. Our second is also full with 8. And then our third has 4. So 1, 2, 3, 4. Okay, potassium. On the periodic table, potassium's over here. So the atomic number of potassium is 19. So that means we have 19 protons and 19 electrons. So we can have 2 in our first energy level, then 8, so that's 10. So we've got 9 left, so we have another, the third one can be full, and that'll leave 1. So you can see I've drawn another energy level here. So we have a full first energy level, a full second energy level, okay, a full third. Now if you don't have full, I usually go 1, 2, 3, 4. So I go around in a clockwise fashion, and then I start going again. So 5, 6, 7, 8. So just doesn't have to be done that way, but that's just what I do. And then we have 1 in the last one. So hopefully that's a bit clearer.